Let's start that. Also, turns out that other PDE question about the heat equation on a sphere wasn't that difficult. Oh, cool. Yeah, I did see that. We didn't get to it. What's up, Fatih?
Yeah.
All right, let's go spin the wheel. We got a lot of people already in the queue. Actual officehours.com. Okay. QQQ. Wow, look at all these fun ones. Nice. Okay, cool. Let's go spin the winner. Whose question is the fifth question of today? Wow, Equity, you were first to ask. And you were first to have your question done. Nice. The given conditions made everything uniform, so it wasn't dependent on the radius. Okay, cool. So you could use like some symmetry arguments. Are you a chess player? I do play chess. I don't think I'm the best chess player. I'm decent. I'm like probably like 1100, 1200 elo. Okay. The semi-log plot. Ooh, the reason why this is called semi-log is this is log on the top and this is linear. I guess we call this like log-lin. It's another way to call it, log-lin. For the function g in question 3. Okay, well, I don't have question 3, unfortunately. Write an equation for the linear model for the semi-log plot of the form y is equal to blah, 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 blah. Cool. Okay. So this looks linear, right? Write an equation for the linear model of the semi-log plot of the form. Oh, I see. Okay, well, I think it's all log base 10 at least, right? So we just need some data points, yeah? Right? In this case, yeah, x is linear. But then we're graphing the log of y, are we not? We're saying the log base 10 of y is equal to like some mx plus b. Right, which, yes, when you want to solve that for y, you then, you know, raise everything to the 10th power. And you get that y is equal to 10 to the mx plus b. I don't really get this. I think this form is wrong. Right? Or I see. They want me to write the slope and the y-intercept in terms of those two things. Yeah. Is that what's happening? Anyways, yeah, we have some points. So yeah, this is yeah, they separated it out. Okay, cool. Yeah, so we got some. Yeah, so how you read these, right? So for instance, this is 10 to the 3, so this is 1,000. Then this is 2,000. This is 3,000. And then so forth. And then eventually you get to 10,000. Notice how the spacing gets smaller as you get closer to like the top end of the next power of 10. The reason why log plots are really dope is they allow you to analyze things kind of as an order of magnitude. I can see that like, oh, stuff here is, you know, on the order of magnitude of tens. Stuff here is on the order of the magnitude of hundreds. Stuff here is on the order of magnitude of thousands. Whereas if you had this on a linear plot, this would be like way down here. This would be like way up here, and then this would be like to the sky. Like you just can't see shit. Yeah. Okay. So 1030 I agree is a point, and you want to say 2090? Yeah, I guess that is a point. Yeah, sure, 2090. $20,90. Okay. So then let's do it this way. Okay. So what we get. So let me figure out how I want to do this with the slope. Okay, slope is y2 minus y1. I've never been good at log equations, so I've been practicing them. Nice. Yeah, logs are great. I use them a lot in my PhD program because a lot of our data was very crazy different orders of magnitude. And the only way you can visualize that data is with, yeah, log ln. Also, if stuff is like in frequency space, usually you want this as a logarithm as well because you care about things at like the hertz, kilohertz, megahertz, gigahertz. And you don't want, and it's a lot easier to see data that way. I would show some examples. I have probably some graphs that I've done with Loglin. They look cool. Also because in physics and waves, a lot of times the power goes as like the frequency squared. So you want to also kind of like incorporate that. Like lower frequency stuff doesn't, I guess, matter as much as like the higher stuff. Yeah, okay, let's do this. All right, y2 minus y1. So that's 90 minus 30 over 20 minus 10. So that gets me 60 over 10. So m is equal to 6. Cool, great. All right, so m equals 6. And then they want to figure out the y-intercept. Okay. So if I know y is equal to like 6x plus b. Semi-log, yeah. Yeah. Actually, no. I still have to keep it in this form, don't I? Yeah. Sorry, I have to do this. I have to say log base 10 of log base 10 of, let's do this point, of 30. You think the slope is 12? Why is the slope 12? Do 10 comma 30? Yeah, I'm doing 10 comma 30. Never mind, I've lost my mind.
Oh no.
You've lost the... This is how the graph is working. You're graphing the log base 10 of y, and this is like effectively what like y prime is, right? This is a graph of y prime. And y prime versus x is linear, is what we're saying. Yeah, and they're super useful in StatMex when multiplicities get crazy, yeah. So... I think we can do this way as well. Log base 10 of 30 is then equal to the slope, which is 6. Let me think 1 sec. Oh, wait a minute. I gotta think how this works. These are points, and yeah, it looks like a line. And the line of that is 6. How to get 90 minus 30? I took this point. Which, okay, I see my error now. Sorry. This is not... These are not y coordinates. Sorry, these need to be y prime coordinates. These are y prime coordinates is what you need. Aha. Okay, I see what I want now. My bad. Okay, this is what I want. Okay. M is equal to log base 3 of 90. Or not log base 3, log base 10. Yes, exactly, Jeff. You're right. Yep, I had that wrong. Yeah. I got confused because people were telling me 1030 and 2090. It's wrong. Those are not the points. You want to use like the y prime points. And the y prime point here is log base 10 of 30. This one's log base 10 of 90. You use 50 versus x. I think it's pretty linear here, dog. No? That's pretty fucking straight. I agree that, but then I have to like estimate in between here because this is like not exactly on a line. This one's pretty much smack dab on 9. Can you explain why it's log 30 and not just 30? Yeah, sure. Okay, because okay, okay, for instance. This is where things get confusing. Do you see how these are evenly spaced, right? Do you see how there's an even spacing between 100 and 1,000, and then that spacing is also the same as between 100 and 10, that makes no sense on a linear graph, right? On a linear graph, the spacing between like 10 and let's say, for instance, this is 10 and 100. 100 and 1,000 would be like way up here, right? This only incorporates 90 numbers. This incorporates 900. Sorry, 1,000. So what we do is, and again, this is why the log scale is cool for incorporating like what are the differences within the magnitudes. Yes, this is 10. Yes, this is 100. But really what this is this is log base 10 of 10. So really this is like 1. And then this is log base 10 of 100, which is equal to 2. And then this is log base 10 of 1,000, which is equal to 3. And then this is log base 10 of 10,000, which is equal to 4. Now the graph makes sense, right? Now the difference, quote unquote, between 10 and 100 is like 1, whereas the difference between 100 and 1,000 is also 1 on this new scale of every y value is now the log of that y value. So this is like it's a new coordinate system. It's like y prime. Okay, so if I describe a line, yes, yeah, in a normal graph, yeah, but on the normal graph it wouldn't be linear then, right? On a normal graph, if you wanted, let's say, for instance, you graph these 2 points. Let's say you graphed, what was that? Let's say you graphed, what was it, 10 and like 30? Or was it 10 and, what was it, 10 and what? Yeah, 10, 30, 20, 90. Okay. So 10, 30, 20, I don't know, what's 3 of these indices, right? 90. Like, cool. Yeah, this looks linear so far. But then the next one is 30, and then it's 200, basically. Okay. How far would 200 be up, right? 200 would be double this, at least. Ugh, I hate when that happens. Right? So 200 would be like probably like up here somewhere. So the key thing is that, like, if you were to graph this, let's see, that kind of looks the same, yeah. This ends up looking like exponential on a normal graph, but we're trying to describe it as a linear graph, like as a line. So on a normal on a linear graph, this ends up looking not very linear. It's going to look something like this. Okay, so it doesn't make sense to try to figure out the slope here in linear coordinates, because in linear coordinates this does not behave like a line. If instead every y coordinate has a log applied to it first, now this ends up looking like a line just from how the data works. The way you can see this is, let's say, for instance, our data was yeah, only then can you see it's linear and prove that it correlates. Lasagna.
Oh no.
What's up, JC? Yeah, let's say, for instance, your graph was y is equal to x squared. Okay, let's just do that, right? Y equals x squared, looks something like this. This is not something you want to approximate with a linear graph, right? But let me think. If I were to take the log of the right side, right, then I would get like y is equal to log of x squared. So I get y is equal to, what was that, 2 log x? Is this the way I want to do it? I forget. Yeah, so this is a case of if you graphed y versus the log of x, then it would be a line. Yeah, I don't want log, I want log ln, right? How do I do this? Okay, y equals square root of x. You want me to do that? Okay, we can do that as well. I don't think I want y equals... like that? Y is equal to x to the 1/2? Oh, if you do y equal 2 to the x. Okay, let's try that. Sorry. I like that better. Yeah, okay. If we do y is equal to 2 to the x, that's, again, going to, like, blow up and stuff. Yeah, this is what happens. Okay. Now, if I take the log of both sides, I get log of y is equal to log of 2 to the x. Okay. X comes down. So now I get log y is equal to x log 2. Okay. This is just a number, right? You can just pretend that this is just some number, okay? This is now the slope for something that looks like y prime equals mx. Do you see? Yeah. I suggest e to the x in terms of e to the 2i pi. Yeah, that's another cool one. We could do that as well. Here, let me just show you. Okay. Yeah. Yeah, so for instance, this is a graph of e to the x on a linear graph, okay? Right? If I take the ln of both sides, right? So instead of graphing e to the x, I'm going to graph the ln of e to the x. Do you see how that's now a line? Because that's the same thing as x ln of e, which is just x times 1. Oh, can you? Okay, let's try that as well. Yeah, okay, here you go. So this is e to the x. Maybe in the settings we can change it. More options. Yeah, here you go. Okay, here's cool. Yeah, no, they do. So if you go to settings here, and then let's make the y-axis logarithmic. You see how it's a straight line? Because now, instead of graphing, right, 1, 2, 3, 4, we're graphing like the log of 1, the log of 2, the log of 3, the log of 4. Yeah, that's true as well. Crazy run. The chat in the button is really disturbing. What's the chat? What chat are we talking about? Okay. You can choose whatever base you want. I think in this case you want log base 10 because it's like 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. That's the other thing here. Do you see how this is like 10 to the 0? What you're effectively doing when you're looking at a log lin graph is you only care about the exponent. Like, do you see how this is 0? This is 1. This is 2. This is 3. And so now this makes sense as a graph for the spacing between these grid points to be the same. The reason why the spacing is the same is because in logarithmic land, the spacing between 10 to the 1 and 10 to the 2 is the same as the spacing between 10 to the 2 and 10 to the 3. The spacing is just 1. Yeah. Does that make sense, Equity? Like... And so, if it's describing a line here, then I need to like convert all these into, well, where would they be on the log y graph, right? So if something was 10, right? If the y value was equal to 10, I would want that to correspond to like 1 on my graph, right? And if the y value of my point was 100, I need that to correspond to 2. Right? That's why this, this kind of looks like, I don't know, like 1.4, right? This looks like 1.9. This looks like 2.2. This looks like 2.7. This looks like 3.2. Or B, because you're American.
Surprise, motherfucker.
Yeah, exactly, yeah. Okay, sorry. I made a huge mess of all this stuff here. So let me just do it down here real quick. Okay. All right, so we had our points. We have this point, which is 10, 30. I agree with that. And then we have here, which is 20 comma 90. Yes, the horizontal lines are multiples of 10. Yeah. Okay. So, my model is the log of y is equal to mx plus b. Notice how this is linear, and this is kind of like now what I would call like y prime is equal to mx plus b. Yeah, and this is y prime. Okay. So when finding the slope, I need to do y prime minus y prime over x minus x. Right? It's rise over run, but that rise is in log land. So I'm going to say the log of 90 minus the log of 30 all over 20 minus 20 minus 10. I'm constantly learning German. Nice.
Good job.
I met a cute German girl when I was in Tokyo. Her name was Annika. Kind of inspired me to learn a little bit of German. It's pretty close to English, no? All right, so so when you subtract logs, remember it's the same thing as dividing logs. So this is the same thing as the log of 90 over 30. And then this is over 10. Okay. And this is, of course, right, this is equal to m. So now I would get that m is equal to the log of 3 all over 10, which, what do we want to do there? What would it look like in a standard Cartesian plane? It would look exponential. It would start going up. I'm so sad that we left the EU. Yeah, I heard Brexit's coming back together though. They're doing a reunion tour. Okay, the same way to write this would be like 1/10 log of 3, and is that what they wanted? No, they want a single log. Okay, fine. Okay, so then you need to write this. So this has to go up as an exponent. Yeah, which is kind of annoying. So it's log of 3 to the 1/10. Is that correct? What was the answer that they said? What did they want? Equity? What did they say the answer was? That's just for the slope. And then if you want to figure out the y-intercept, you got to plug back in, okay? So I'm going to say log of 30 is equal to 1 over 10 log of 3. And then, oh, I see. They want it in base n. Oh, I see what we're going to do. Yeah, we're going to make this a 3. Oh, that's really cute. I see how they're going to do it. One sec. We'll get there. We'll get there. Everything we're doing right now is in log base 10, but we get to choose what the base is later. Okay, so now I'm solving for the y-intercept. Solve for. This is kind of a tricky question. So we're solving for the y-intercept, which is y prime is equal to m. And then we need to say what the x value is, right? The x value was 10. And then it's going to be plus b, right? So what that's going to give us is log of 30, 10's cancel, is equal to log of 3 plus b. So if you subtract that over, b is equal to the log of 10. Oh, which is nice. It's just equal to 1. Or it's log base 10 of 10 is what it is, yeah? But, okay, they want it to all be the same thing. Okay. So, now we have, okay, y prime. I'm not going to say y. Y prime. I also think this is kind of, this is kind of misleading. Shouldn't this be y prime? Okay. It's the equation of the Write an equation for the linear model. Yeah, that should be y prime, not just y. Or, wait. Let me just write it this way. Okay. Log of y is equal to log of, so it's gonna be 1/10. No, log of 3 to the 1/10 x plus log of 10. Right, okay. And then I think I see what happens here. This is the fit. This is for sure the fit. This is what the fit is. Yeah, okay, cool. Yeah, they're fucking up here though, dude. Okay, one sec. This is kind of wrong. They say y is equal to that? No, y prime is equal to that. Right? This is what his teacher said. Yeah. It's that the log of y is equal to this. Not y. Unless, yeah, this should be y prime. Why did they go from y to log y? Yeah, but yeah, see, here's the cute thing. Your teacher then does this on the next step. They say, "Oh, okay, but if we actually want," so this is so funny. Ich werd schlafen, wer ich müde bin. Gute Nacht, Dr. Gold. Are you going to bed? Okay. Night, JC. Yeah, so this was the second part. It was like, use the linear model from part A to write the equation of the exponential model. Yeah. So this is y prime. Where y prime is this coordinate system. And then we want to convert that to like what a regular y is. Well, I know that y prime is the same thing as log y. Okay, so then you get to here. Right? And if you want to get y by itself, now you have to raise 10 to both sides. Okay? So that'll get you... So here, yeah. Which is ugly as anything, dude. Like, what? I guess it simplifies out now, see. Or actually, let me just drag this down. Okay. So then what you do is you do 10 to the... Okay. This 10 to the log base 10 of y is just y. This, by exponent rules, is the same thing as 10 to the log of 3 to the 1/10 times 10 to the log of 10. Right? Which, if we're using base 10 for log, before exponentiating, don't you have to combine? I mean, you could. Yeah, you mean like you want to combine these? You could, but you can also just say this is the same thing as like x to the a plus b is the same thing as x to the a, x to the b. And that's just what I'm doing here. And your teacher does the same thing here. They do x to the a, x times x to the b. Because this is just 10. And then this is going to be, and sorry, there was an x somewhere. Sorry, there was still an x here. All right. Dun, 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 dun. 10, right, because this is separate from this. Let me think how that works. Yeah, okay. So, remember that the x is not a part of the log equity. the x is multiplying to the log. So you have 10 to the something times something. And when you have two exponents multiplying by each other, you can take this exponent and you can put it up top. Okay? Because this is x to the a times b is the same thing as x to the a to the b. You gotta get a little bit careful with the parentheses, okay? Because then it's technically this. And now here, this is the same thing as so 10 to the log base 10 of something, that cancels. And so you just get 3 to the 1/10. But then all of this is to the x. And so this follows your form of y is equal to a to the x times b. Which I think is what they wanted, right? Or a to the bx. Sure. Sorry. Yeah, a to the x times b. So y equals... Wait, no. They wanted b to the x, sorry. B to the x times a. So y is equal to a. B to the x is the same thing as 10 times 3 to the 1/10 to the x. What happened to the x? Did you see that, Equity? Sorry, the x was here. Right? I did 10 to the whole thing. So that means I need 10 to this times 10 to this. 10 to this is just 10. Oh, and I forgot to copy it? Okay, thanks. Yeah. And then, by this rule, x to the a times b. Okay, cool. There you go. Nice font in chat. Curious? What's nice font? What's a nice font? Okay, cool. Nice. All right, cool. Tricky question. This one.
That's dope.
We give a shout out to Zach.
Well done.
Okay, cool. Zach, have we decided a time when we're doing the 16 game? Yep. Or like when I can start like announcing. You saw me plugging it for Justin, right? Justin Barthheit. I was telling him, I was like, yeah, come on by, dude. Come play. Or at least come watch. Okay, nice. All right. Let's save the screenshot for that one. Feel free to go down that rabbit hole. Where did that save? There we go. Dun. All right, let's go see who else we got. I got an hour. All right, let's go spin a winner. See who's gonna take home the prize of next question we go over. Looks pretty even, right? Oh, it's not working. Dr. Novice! You got selected with a 12.4% chance, Dr. Novice. Oh dear, what's going on here? Is this fluid mechanics? I don't like fluid mechanics.
Oh, dang it.
Okay. Ask what's pi rounded? It's basically 3. An object in the shape of a truncated solid sphere, radius r, is kept at the bottom of a tank as shown. The distance from the center of the sphere to the bottom of the tank is L. The tank is slowly now filled with water, assuming the truncated sphere is fixed to the bottom of the tank so that the bottom surface does not get wet. The variation of the vertical upward force exerted on the object by the water with height h of the water is best represented. Okay, this is buoyancy, no? Oh, it's okay, breasticles. The solution to the auxiliary equation of a differential equation was the eigenvalues. I meant to say the eigenvalues of the derivative operator. Oh. Okay. Right. I think this has to do with man, what's the buoyancy guy's name? What is it? Buoyancy law thing? Buoyancy law thing. Archimedes. Right, okay. Archimedes' principle says that the buoyant force on an object is equal to the force of gravity that would have acted on the fluid it's displacing. Okay? So, for instance, simple case. Things that displace water. Yeah, exactly right. So, if you have water here, and then let's say you have a sphere of some radius r, okay? The buoyant force that causes this thing to want to raise, force buoyancy would be equal to the volume of water that it displaces. So that's 4/3 pi r cubed. That's the volume. And then you would take that volume times density and then times gravity. This would give you, like, the force of that amount of water. Being pulled down. Yeah. I don't remember the exact proof from where it comes from, but it's kind of a useful thing to know, Archimedes' principle. So, your chat has a cute font. That's cool. Question: can we view this as the difference of the forces exerted on the body by gravity and on an equal amount of water by gravity? Well, okay. The net force on this thing, though, right? The net force would be equal to the force of gravity of the object. Negative of that plus the buoyant force. So, like, so there has to be, there is some force of gravity due to just the container that's displacing that, right? This is going to have some mass that's pulling it down, but the amount of liquid that it displaces, that technically pulls it up. So the net force then depends on, like, the balance between the two. Right. The pressure only depends on the height alone. That justifies the equality. Oh, okay, I see. The pressure... Well, buoyancy actually doesn't matter, right? Whether it's here or whether it's here, right? The buoyant force is the same. The buoyant force is equal to what it would be if the ball were filled with water. Correct. Well, what the weight of that stuff would be? It says the bottom does not get wet, so we can't use that law. Also, I've never seen someone use right with RYT. What? Oh my god, what? RYT, right? Really? You guys, is that the new way you guys spell right? RYT? That's degenerate, dude. I don't think it matters. The surface does not get wet. Well, the bottom surface doesn't get wet. I think what they're saying is that okay, this is dry, I guess, yeah. So technically there's no upwards force of water underneath it. Yeah, but he didn't write the GH as well, breasticles.
Oh no.
I don't know why the bottom surface does not get wet, why that matters. My general thinking is to figure out, like, if the water line is here, for instance, what amount of volume is being displaced. And that should be the force. And then, like, right, as you go up, you're going to start displacing... you're going to displace more volume, but not as quickly. It matters if the density changes, then the integral of the pressure on the surface also changes. So the principle holds even when the density changes. Oh, you guys are talking about balloons now. I don't know what the fuck this... I mean, they did bold it, though. I mean... Like, that does worry me. The variation of the vertical upwards force exerted on the object by the water with the height is best represented... I want to say it's this. I want to say it increases rapidly because as you start going up, this thing starts widening, and so you're going to start displacing a lot more volume. But then as you reach some, like, inflection point, I don't know, some amount up, then you're no longer, or actually, ooh, interesting here. Yeah, after 2L, the amount of force pointing up should be the same, no? It should just be constant. Unless you can't use Archimedes' principle here, then I'm lost. Shouldn't it decrease? Archimedes' principle says it doesn't matter. Because it's the pressure difference, right? The buoyant force is the difference between the pressure here and the pressure here. So as you increase the water level, which is linear, right? The force, the pressure due to the water is rho GH. The delta is still the same. Okay, one second. It happens if an upward force is applied by water on the bottom surface only. Since it's fixed, the downward force is also applied after the water fills the half. I don't know what he means by that. What class is this for, dog? Is this like some weird engineering thing? I've never seen this before. I'm sending this to chat. It's not a perfect sphere. A levels. Interesting. I don't know. We'll see. Let's see. In all my 15 years of teaching physics, I've never seen this problem. I've never seen something like it. So I'm going to learn something new today. You talking about L? Yeah, L is the radius, basically, right? Is L equal to R? Sorry. The distance... Oh, no. L is the distance from... Sorry, L is less than the radius, right? Yeah, I agree they have R and L. And then they have 2L as well. That's no sphere. That's no moon. Alright, chat's taking a while, dude. Chat, what are you doing, dude? Let's go ask Gemini. Because once the water passes the halfway point, the upward force is going to lessen because there's less volume and the force of the water applied downwards on the ball decreases as well. So it would increase fast and then die off quickly? I don't know. Okay, cool. All right. So, yeah, there's no upward pressure acting on the flat bottom. The net vertical force is strictly the sum of the vertical components of water pressure along this. All right. Usually buoyancy. However, because the bottom is sealed, it doesn't apply. Oh, no.
Oh, no.
Okay. Water pushes upwards on the lower half of the sphere. The parts curving outward and down. Yes. Once the water rises above the equator, it pushes downwards. Okay, I can agree with that. I see. So you're saying that when the water is here, this pushes upwards. But then once you get past whatever the halfway point, now the additional water you add, well, first of all, yeah, water here is no longer pushing upward. It's all pushing downwards. And this amount that was pushing upwards is not increasing. So let's see. The vertical upward force, I think it would increase up to L, and then it should start decreasing. But none of these have it decreasing. Interesting. Okay, let's keep reading. The water has not reached the sphere. F equals 0. Wait, what does it mean? What? I think Gemini's fucking up. Because, like, the water's definitely reached the sphere at H equals 0. Pressure acts perpendicular to the surface. Sure. The upward force is at maximum because any additional water will start covering it. Right. As the water rises above our center, it begins to push downwards on the top half. This downward force starts to cancel out the upwards force, and thus F must decrease. Okay. They say the correct answer is 4. Let's see if that makes sense. Here's the interesting thing. Okay. I agree that the force upward should increase. Yeah, no, I see that now, your friend. I get that. I get that it happens like perpendicular to it. Uh-huh. Cool. This time, also, the resultant is in the upwards direction, even though there's downwards resultant from the upper section. Ah, okay, I see what they're saying. The force from the bottom section increases more. I see. Because, yes, as you raise the water level, the pressure here does increase. Okay. Okay. I can get behind that. Right, and then also, because the water here is at a higher level, it's going to have less pressure pushing down than this will have pushing up. Okay, there we go. Okay, cool. I still want to know the difference between 4 and 5. Yeah, wait, aren't they the same? And I think I see what happens is eventually the water level becomes so large that the difference in pressure between the top and the top and the bottom of the equator is negligible.
You done messed up, Aaron!
And so then you can say that it's 0. Gradient after R is constant. Okay. I think they're saying this. You see how this is constant? And I guess this still has like some curvature to it. Is that what they're arguing? Or wait, are they even arguing this? L plus R? Oh, I see. I think I see. There's like a curvature here, but then this is a straight line. So the sphere gets pushed down. Yes. Yeah. The reason is because the sphere is lacking fluid here at the bottom to push it up. This would be at a... This part... Like, in a normal sphere that's not had its balls chopped off...
Oh, no.
At the bottom. The pressure here is less than the pressure here. So this kind of performs like a net upwards force on the object. Yeah, okay. I get it. This is a cool explanation. I've never seen this before, but yeah, cool question, not your friend. That was fun. Well, actually, it's from Dr. Novice, but... Dr. Novice... This is Dr. Novice's question, but not your friend was participating. And water force acts perpendicular to the surface, not opposite of gravity. Correct. Yeah. Pressure is a scalar. But it acts perpendicular to a surface. Yeah, Dr. Novice says cool. Fascinating. I would have gotten that wrong on an A-level question. No way I would have gotten that wrong.
Oh, no.
UK people. Such tricky questions. Yeah. Okay, cool. Let's see what else we got. Well, that's my podcast. All right. Let's choose a winner.
Let's go gambling!
Yeah, it acts perpendicular to all surfaces. Correct. Gladiator! What do you got for me, Gladiator? Ooh, these are some nasty integrals. Nasty. Wheels rigged again.
You're not that guy, pal. Trust me. You're not that guy.
No broken kidney. Broken kidney always like breaks me, dude. Really? Gladiator, why do you have to do these? These are just obscene. Absolutely obscene. I mean, some of these are not terrible. Like, this one isn't the worst thing in the world, I guess, right? I guess this one is not bad either. I don't know how to do this one, though. Actually, I do see it. Oh, I see it. Oh, this one's a trick. Yeah, watch this. It's actually pretty cool. Okay. Yeah. Okay. No. I think the top one you want to use U sub. Yeah. Femvox is right. Yeah. I saw the U sub. I was like, wait a minute. This is going to be 20x plus 4x to the fourth. There's an x to the fourth. There's like a 4x. Maybe it works. Okay, we can do this one real quick. I don't know if I'll do all these, Gladiator. Maybe pick which ones you really have troubles with. Actually, you know what I'm going to do? I'll just show you like how to start them and then assume you can do them. You think they're all U sub? Okay. Well, then let's go over like what you would pick for U. Okay, so in this case, I would pick U to be, I'm going to rearrange. No, I'm going to leave it. 10x squared plus x to the fifth minus 2. So then du is equal to 20x plus 5x to the fourth, which is, and then this is all dx. Yeah, right, exactly. Which, if you pull out the 5, right? This is 5 times 4x plus x to the fourth dx. Which, yeah. So you kind of got this, right? This right here is kind of du, right? It's du times du divided by 5. Right. So this right here is du over 5. How do you know what you want u to be? Good question, Hitman. So in general, I mean, anything could be. I could have picked this to be u. You want to pick u such that the derivative of u shows up in some form kind of close by. So here, I noticed that the derivative of this got me something of x to the fourth, which was out front. So that tells me I'm on the right path. Because then, look, this whole thing is u. And so what you eventually end up getting is, I'm not going to put the bounds. Don't murder me. Integral of 3. And then this becomes u to the 6th. And then you have, this whole thing was now du over 5. Okay? So now this is just the integral of 3/5 u to the 6th du. And this is an easy integral to do. Yeah. The other way to do this is, so once you get your du, and you get it like this, rearrange this for dx. So in this case, if I solved this for dx, I would have gotten that dx is equal to du divided by 4x plus x to the 4th, right? Yeah, you see it now? Yeah. And then watch if I do my integral, right? So I have integral, and it would be, I'm not going to put the bounds. And then it's 3, right? 4x plus x to the 4th. And then this is now u to the 6th. And then instead of writing dx, you write du over 4x plus x to the 4th. And then here's the cool thing. This will cancel out this. Okay? And so now your integral is left just in terms of u. So if you do u sub and you don't have any more of the old variable left, then you did a good job.
Good job.
How would you change the bounds? Well, not terrible. So instead of the bounds going from 0 to 1, you would plug in 0 into here. So now the bounds would go from -2 to 10 plus 5. 10 plus 1 is 11 minus 2, 10 to 9. Sorry, -2 to 9. So this is what they would do. These would be the new bounds. You plug in this thing in for x to get what your new u bounds are. Yeah, or you can do what I do is I don't substitute the bounds. I'll do this. I'll do the integral, right? Which would have given me 3 over 30 u to the 7th. No, wait. Fuck. No. 3 over 35 u to the 7th, right? Right. Raise the power, divide by new power. And then I would substitute this back in for u. And then you can... So then you'd get 3 over 35. And then this would be 10x squared plus x to the 5th minus 2. And then you can put back your old bounds, which would be from 0 to 1. It's the same thing. A lot of times, if your integrals don't have bounds, you have to do this step anyways of, like, putting back in what u was. Because the original question asked for an integral in terms of x, not in terms of u. U is kind of like a little short, little cheating step we do in between to make it work. Gladiator says, my badge just came back.
Oh no.
Okay, well, you can rewatch the recording. Gladiator. I was just showing, like, how to pick what u was. Here, I'll show you how to pick u for the other ones real quick. And then you can do the integrals. So, yeah, integrals are great. These are very hard, though. These are very hard integrals. Not necessarily easy. So in this case, you could say u is equal to 9 minus 5 sine of 2t. And then we just got to hope up that shows up somewhere else, right? So then du would be equal to... so derivative of sine is cosine, but then you have a chain rule with a 2. So it's -5 times 2, which is -10 cosine of 2t dt. And then bingo bango. See how cosine 2t dt shows up as well? So this would just become 8 over the square root of u, which is 8 times u to the 1/2, and then that's an easy integral to do. You got confused by the PDE problem? I did too, honestly.
Oh no.
So this would be the integral of You'd have to divide by 10. So negative 8 over 10, and then it would be u to the negative 1/2 du. I think that's how that would work. Yeah, that's how that one would work. This one's easy. You would pick u is equal to the cosine of z. So then du is equal to negative sine z dz. Which, look, sine z dz. So this just ends up equaling, but you need a negative, so you're going to put another negative out front. You're going to say this is the same thing as the negative of u to the third du. Pink moon today. Is it a pink moon? Don't tell the flat earther.
Oh no.
If you're changing out the screens. This is an interesting one. Oh, I know how this works. This is actually really cool. Okay. I think I'm going to pick this to be u. I'm going to say u is equal to 1 minus, and then I'm going to rewrite this in terms of exponents. So square root is to the 1/2, but then that's to the third. So this is minus w to the 3/2. So then du is equal to negative 3/2 w to the 1/2. Do you see how that, and then this is dw. You see how w to the 1/2 shows up here? Yeah, so this one's nice. Yeah. Yeah, the w to the 3/2 is the trick. Yeah. You got to recognize that the cube root, the cube of something, the square root of something cubed is to the 3/2. And then this one, yeah, I agree. This isn't u sub. This is just two different integrals, right? This is a integral you can just do. And then this one, you end up saying that this, say like u is equal to 5 minus 2y. So then du is just equal to negative 2 dy. And so, yeah, that just becomes like an ln thing. Yeah, technically the last one, Jeff, it's just a really easy one, so writing the step isn't, yeah. This you can just do. You call this whole thing here. This is two different u subs. You end up calling this u as well. Or actually, I guess you can call the whole thing u. I guess u is the same thing every time, right? Oh, that's actually kind of cool. Yeah, so this one just becomes negative 1/2 u to the 1/3 plus minus 7/2 u to the negative 1/2, and then it's du, right? Yeah, you're slowly understanding integrals. These are difficult. This is like the hardest parts of u sub I've seen. Generally, a u sub question would just be something like this. They would say like, oh, what's the integral of, I don't know, like 2x squared, and then you'd say like x to the third plus 2 to the 5th dx. And then what you recognize is that, oh, if this is u, then du is equal to 3x squared dx. And look, x squared dx shows up outside. So you'll be good. Correct. Correct breasticles. This should have been u to the minus 1. Good catch. Good catch. This should have been u to the minus 1. I was getting happy with all the square roots. Okay, cool. Yeah, so here's kind of like a roadmap of how to do them. And then you just have to do the integrals. Cool. Yeah, these are hard ones. Nice. Good. I'm glad you're like, you know, self-teaching, trying to learn shit yourself. That's really cool, man. Yeah, if you're ever like bored in your class because, I don't know, your teacher's not doing shit.
Oh no.
Go learn stuff yourself. You'll have a fun time. Oh, I didn't need to post this image twice. Yes. Make sure you go join the Discord, because every time we do one of these questions, I post the question. I post the screenshot of what we did for the question, and then also there's a link here to the YouTube recording, and it's also timestamped, so it'll tell you exactly where in the recording we did it, so you don't have to go like scrubbing through like hours of stuff to go find it. And then the link for the Discord is in the same place that people are uploading their questions, actualofficehours.com. Just go click join our Discord. Go do it. Okay. Let's see what else we got. Pretty even playing field today. Crazy thing is, I have a cousin who's in 7th grade doing integrals in Kumon. Dude, their logo is so sad. Who came up with their logo, dude? You guys know what I'm talking about? Like, this doesn't really inspire. Wait, what? This looks like some kid who's like lost.
Oh no.
Like, what? It's like, come on, dog. Come on. Why can't you do this? Come on. I don't want to send you to the glue factory.
Oh no.
It's just a hilarious. I don't know who in corporate thought that was a good idea for a logo. It'd be a good logo for anything engineering based. Yeah, just like, I'm fucking confused. It's losing its morale. I think it encodes the general engineering. Yeah. What was the oh man. So one of our students who's been in the server for a while just got accepted to University of Waterloo, and there's a whole meme about what they call like the Waterloo effect. And it's like people that start at Waterloo and then like what happens at the end of like 4 years of, you know, engineering. There's some really good ones. This is also apparently the Waterloo effect. Students share their progress from year 1 to year 5 in engineering school. You just like lose all happiness or something. Wait, why can't I open this? I'd like to visit this, please. No, there's an app. I don't want the app. Oh, man, I don't want the app. Why can't I just watch the website? Oh, here you go. There you go. We got the picture of it. Yeah. So, you know, lots of youth and happiness in its face. There's a lot of scary... this man has seen a lot of things. I mean, this person grew facial hair, I guess. Not terribly different. This is an effect. Oh, man. Yeah. Well, this guy's just like really high, or like hasn't gone to sleep in a while in this bottom picture. Wow, lost all his hair. Damn. Yeah. So, anyways. Yeah, engineering school probably. Let's go see. Whose question are we going to do today? Who's next? Who's next? Who's next? Spin, spin, spin. Who's going to win?
Gambling!
Rascal says it's fucking rigged.
Oh no.
FJE. To be honest, they did submit kind of first, though. How many years since we last admitted a state to the union? Dr. Gold sucks.txt.
Oh no.
This is you, Jeff. I know this is. I got a friend whose brother went to A&M for petroleum engineering. His senior photos make him look like a 15, 16-year-old, and now he's in his 20s and balding. Damn. Yeah, how long has it been since we last admitted a state? What was the last state admitted? Was it my tricky anagram? Didn't yeah. Yeah, FJE 6260. All right. Was it Hawaii? Or was it Alaska? We should turn the wheel into a fruit machine. Hawaii was the last one. That's cool. 1959. Fascinating. So wait a minute. During Pearl Harbor, Hawaii wasn't a state? I didn't know that. That's crazy. Let's see. Yeah, I knew it was Hawaii or Alaska. Oh, so how many years since 1959?
Oh shit.
Oh no.
I know where this is going, dude. I know where this is going. I know where this is going. I think technically 66.8 years. I think it's 66.8 years. It's not that. Because it was August 21st. It's, oh damn, it's 66 years and 7 months.
Oh no.
Did you account for this as well? Did you account for this as well? Did you account for the 7 months? I would tell you it's just 2.1 billion seconds.
Oh no.
Okay, cool. Yes, close on the 6-7 meme. Sadly, I was going for 6-7. You got close, dude. You just lose another year. Okay. Cool question. Thanks, Jeff. Let's spin. I got... How much time do I have left? 30 minutes. Let's see what we can do.
Let's go gambling!
Lucky cat is lucky!
Let's go!
Lucky cat is lucky. Breasticle says this is fucking rigged.
Disqualified, motherfucker.
It's so rigged. Breasticles, what if I like secretly put in the code like if name equals breasticles, you know, decrease number of votes by a factor of a half. This is why I don't buy lotto tickets. What's up, Dr. Cook? Yeah. Why have luck when you have meth? Dude, what? Okay. I got the test on this Thursday. He just announced it today. That's rude. What?
Surprise, motherfucker.
What? You can't announce a test 2 days before. That's not right. That's not right. Okay. So let's see. The y-intercept is 0. I love that. Let's just do it. Y-intercept is 0. Bingo, bango. Point right here. F of x is do not exist for x equals 1 and x equals -1. Oh, I'm going to assume that means it's an asymptote if they say the value doesn't exist, right? Because that means it's plus. I mean, technically it's a whole, but I think we're going to call that an asymptote. First, let's see. We got some stuff for 0, 1, and 2. So let's plot those points at least. Basically a pop quiz. We'd be lucky with more goods. Okay, so let's... All right, if it doesn't exist, I believe that means asymptotic behavior. Put an asymptote here. Put another asymptote here. Cool. It's an odd function, though. That's fun. So odd function means, in terms of the endpoints, it either does this and this, or it does this and this, right? And they say the limit as x... I can't read this. Oh, the limit as x approaches negative infinity is -2. But the limit as x approaches positive infinity is equal to 2. Okay, so we have another asymptote we have to kind of deal with. Let's put that on our graph. So now we have asymptotes here. And we also have asymptotes here. Bingo, bingo. F double prime of 0 is equal to 0. Okay, so that means at 0, it's neither concave up or concave down. It must be an inflection point, which means it's probably going to be something like this, right? But we can figure out where that is because we know it's increasing from -1 to 1. All right, so it has to be doing this. And then we also know that the second derivative is positive when it's greater than 0. So it's going to be like this, right? Second derivative is positive. Oh, wait. No. Sorry, that's for x is greater than 1. I want to know in between. This is what I want to know. Okay. In between -1 and 0, so between -1 and 0, it's concave down. Right? Because that's negative. So I know it has to be something like this. Okay, so I think it's going to do something like this probably. It's probably going to like approach that way. That's that. And then it's the double derivative, sorry, is positive, so it's concave up from 0 to 1. So then it has to do something like this. Okay, so it's got to do something like that. Okay, cool. So we got that. And then we know it's increasing from -1 to 1. I agree with that. That's cool. And then it's positive for when it's greater than 1. Okay. So it's probably going to do this. Right? This would be positive concavity. And also satisfy this, that it approaches 2 from the right. And then I need it to be negative concavity, but also approaching -2. So I think it's going to do like this. 0 is a point of inflection, correct. Yeah, this is a point of inflection. That's when the graph changes from being concave down to being concave up. Do you see how like this is a concave up and then this is technically a concave down? It's like the left half of a concave down. Okay, and then no local min or max points. Yeah, that also makes sense. Because then this is like an inflection point. Yeah. Cool. Dr. Cook says 4 arctan of x divided by pi. It almost looks like arctan, but then there's this weird behavior, right? Like how does this happen? I don't think you have to know the actual graph. How come we're crossing at y equals -2? Because this is an asymptote. I assume it's an asymptote when it says the function does not exist at -1 and 1. So if the function doesn't exist, then I assume it's asymptotic. Also, remember that it has to be concave down here, right? This has to be concave down. And so the only way to approach -2 and be concave down is to come from here. If we had said, for instance, I don't know, that it was... See, it has to, like, approach -2. Now this is concave up. I don't know that it's... Yeah, I mean... So... Yeah. Oh, no, health problems. I'm sorry, Fem.
Oh, no.
Bum, 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 bum. Yeah, health is the fucking worst sometimes, dude. I feel like I've gone through so many like different waves of random... Like, dude, I couldn't use my left side of my body for like 3 weeks. I was like, what? Like, my muscles weren't like responding. It was a real pain in the ass. It's actually funny. A lot of those health issues went away once I finally got hired by like a job, and it is fascinating how much stress manifests issues inside the body. I don't think I realized it at the time, but I was like severely stressed because I was, you know, trying to figure. I had no clue like what I was gonna do for rent sometimes, and I was like tutoring like crazy, just trying to like make things work. And yeah, now that I look back, I had a lot of weird random health issues. Like I had like numbness in weird parts, and like I don't know, I would get like my vision would go blurry sometimes. Like what?
Bruh.
Yeah, old people problems for sure, dude. Nothing makes you feel whole like a regular paycheck. Yeah, seriously. Like I suddenly don't have a lot of those health issues now that I at least see that rent clears every month. I'm very happy about that. For now, at least. Okay. Cool. If I rotate my arm a lot of my arm and it goes completely numb, yeah, that's not good. It turned out, yeah, a lot of the numbness actually that was happening in like the left side of my body, which I noticed immediately because I go to the gym a lot. I lift weights, I bench press, and I was noticing that like my left arm was not firing. It just wasn't doing anything. I think it ended up being like a nerve in my spinal cord was getting pinched, and it was probably getting pinched because inflammation, and it was getting inflammation because of stress. So it does happen. Okay, what's up, Pim? Keep it up. Thanks, Pinhead. Do you pay your rent in gold? No.
Oh, no.
Okay, I think this is done. I think this is good. Right? And I think this is cool as an inflection point, right? Because it's the point where it goes from concave down to concave up. That's okay. And then, yeah, the reason why I think it has to cross here is that if this is concave down, but then this is concave up, right? Just think of it this way. If we have two things like this, the only way, it's discontinuous for it to somehow go from concave down to then concave, or to stay concave down, I guess. Yeah. But it also needs to approach -2 at negative infinity. That's the other rub, right? This has to like go towards negative infinity. So it has to be like the right hand of a concave down thing meeting with the left hand of a concave down thing. Concave down things that increase are this one, and then we know it's increasing from here to here. So it has to be this. And then going from here to here, right? That, or technically from here to here, that's decreasing because I need it to be concave down, right? I couldn't have this. That would be concave up. Yeah, it doesn't reach -2. It technically does reach -2 here. That's okay. You can still have horizontal asymptotes at infinity, but the function can cross them in between. I believe so, right? I theorize it's because I basically God punched by 6,000 pounds. It was, yes, you were involved in a very nasty car accident, I remember. Yeah, that sucks. God punched by 6,000 pounds. What was 6,000 pounds, dude? It's like a G-Wagon. Okay. Dr. Gold.
Yeah, it was a Ram 1500.
There you go, Ram 1500, half-ton truck. That makes sense. That makes sense. Why is there no local max and min? Okay, good question. So in order for there to be a local max or local min, you need the first derivative to be 0, and then you also need the first derivative to change from positive to negative. So note here that the only place the first derivative could, note here, nowhere do they say that the first derivative is equal to 0, except I will assume the first derivative is 0 here. So that would be a candidate for a local max or min, but the problem is that it goes from being positive to being positive. So that's called an inflection point, which is not a max or a min. It's kind of like in 2 dimensions, that's called a saddle. Yeah. That's why there's, yeah. Maxes and mins only occur when the first derivative is 0 and then the first derivative is changing. Yeah, arctan and a piecewise. Yeah, you could do arctan for this, but then, like, I guess this would have to be 1 over x minus 1, 1 over x plus 1, right? Anyways. Okay, cool. I think this question's good. It's in the essence of time. Is there any tips you can give for this topic, concavity and inflection? Yeah. I think it's important to know that, for instance, like concave down is associated with maxes, concave up is associated with minimums. That, yeah, in order for there to be an inflection point, you also need the concavity to change. So the concavity has to be, the second derivative has to be 0, but you also need the second derivative to change from the 2 points. Yeah. So here, right, this changes from concave down to concave up. And we say the second derivative is 0 there, so yeah. That's okay, being an inflection point. Other types of inflection, yeah, I mean, I guess you can have the typical S curve, right? This is another one, which is kind of like the mirror image of this, right? This goes from concave up to concave down. And then this right here is the inflection. But always like kind of think about, oh, well, like, what does this look like? Oh, this looks like this one. And this looks like this one. Third derivative has to be finite. First can be finite. Second is 0. I didn't know that, Jorgen. The third derivative has to be finite. I don't think I've ever seen kids have to deal with the third derivative. Inflection point. Well, yeah, no. So look at this one. This inflection point has a tangent of infinity, right? Tangent of this is infinity. Tangent of this one is 0. So you can have two cases, right? You can have this type of inflection point, which goes from concave down to concave up. Or you can have from concave down to concave up. So you could have, let's get another color. You could have this. So in this case, you see how this is the change in concavity? That has an inflection point with a tangent equal to 0. This is like f prime is equal to 0. This one is like f prime is equal to infinity. Yeah, just changing the concavity directions. Only jerks deal with the third derivative. Oh my god. Zach with the jokes. It has infinite jerk. Yeah. Okay. Zach's always got the puns on lock. All right, let me save this one. This was Lucky Cat. Let's mark it as done. How is it related to the extrema and the global max or min? So to test for global max or min, you have to go find all the local maxes and mins, and then you also need to test the endpoints. And then you just check the y values and see like which one's the biggest and which one's the smallest. Like, let me show real quick. And then I swear we'll get to the next one. Okay, let's say, for instance, you have, something that looks like this, right? So this and this are local maxes. And then let's say the function is defined from here to here. Let's not make it infinite, sorry. So local maxes have concavity, which is negative. So this is f double prime is negative. But then f prime is equal to 0. So if the first derivative is 0, second derivative is negative, those are local maxes. And then it's the opposite for looking at a minimum, for at least with the concavity. So here still f prime is equal to 0, but now f double prime is positive, and that is a case of a local min. And then so what you need to do is you need to consider what are the y values of your local maxes and mins, and also what are the y values of the endpoints. Okay, in this case, You should add a downvote button. Only I have access, so I can go duke it out with the rigged wheel.
Oh no.
Oh man. Okay, so this right here is the global minimum because it's the lowest value out of the maxes, mins, and the endpoints. And then this right here would be the global max. You did this in pre-calc. Cool. Yeah. So here, I'm going to put this also, like, just as a little side note in Pineapple's submission if he wants to see it. Do you do econometrics? I can try. Is there a way for math to see the max like humans do? What do you mean to see the max? How do humans see the max, by the way? First, wait, what? What's the max? All right, let me go. Let me go. There's it's a three-way tie kind of here. Wow, they're all at like 33%. Let's see who's gonna get it.
Let's go gambling!
Presticles is like, come on, dog. Come on, dog. It's Ace! Presticles. I've been shadow banned. Okay. This will probably be a quick one, honestly, because I don't know what to do with this. You know what I do want to do? I'm gonna create my next vibe coding thing to do. Dude, where's the image? Once someone gets selected, I'm gonna come up with like a probability thing that shows like what like how difficult was it for them to not get picked that many times and then suddenly get picked this time. Dude, where is my image? I've copied it 1,000. There you go. Jesus. One sec. Okay, here we're gonna do this one. Holy benzene. Yeah, sure. Okay. I feel like you define one of them to be number 1, and then you just go around as long as it's the least numbers, right? So if this is 1, this is 2, this is 4. Because the other option would have been to say 1, 1, 3, 4, but 1, 3, 4 is not the most efficient way. So I think this one is 1, 2, 4 trichlorobenzene. Yeah, you choose whichever one has the smallest numbers, right? Yeah. I mean, I could have chosen this to be 1, and then that would have been 1, 2, 1, 2, 5, right?
Oh no.
But you don't want that. Like, chemistry is always looking for the most efficient way, right? This is the most efficient way to do it, 1, 2, 4. Same thing here, right? This could have been like 1, 5, 6, but that sucks. So this one is going to be 1, 2, 3, trinitroxide. It's not nitro because it's N. Yeah, nitro is just an N though, not yeah. Nitro would be an N, I think. I think it's 1, 2, 3 nitroxy. Where's my boy JC, dude? I think this is nitroxy. And then that's pentene. It might even be nitroxyl. Oh, they call it nitroxy. Wait. Pro. And then I think it's pentene, yeah. Well, interesting. Here they call it nitrobenzene, even though it has an N and two O's on it. Maybe, one sec. Interesting. We assume, okay, one sec. Yeah, what do we call that? Yeah, okay. Yeah, they do call it nitro. Fine. I'm so illiterate at organic chem. No, you're okay. Dude, OChem is just memorizing just weird shit. Okay. I think this is trinitropentene. Why pentene? Isn't there? Wait, 1, 2, 3, 4. Isn't there 5? 1, 2, 3, 4, 5. No, I can't spell.
Oh no.
Sorry, benzene. Benzene. I read 5. JC was thinking about teaching us. Where's JC? Is the last one ortho? So this is interesting. Which one do you put first? The methyl or the nitro? I think methyl. I would say 1 methyl, 2 nitro benzene. What's ortho? Yeah, there's a name for that. Ortho, that 2 substituents are attached to adjacent carbon atoms. Oh, okay. Ortho is the same thing as saying 1, 2. That's cool. I didn't know about the ortho one. Right, so if things are right next to each other in 1, 2, you can say ortho. Yeah, okay. But I think they have to be the same thing, no? Oh, no. Look, orthochlorophenol. Well, that's because phenol describes the hydroxide attached to it. This is para. Okay, here we go. Ortho-chloro-nitrobenzene, which I think is... Okay, so this is ortho... Cool. I think this is ortho-methyl... nitro benzene. I don't know if that's faster. I guess it's faster than writing like 1, 2. I mean, 1, 2 is actually faster than writing ortho. Or maybe the ortho is used because we don't know which one's 1 and which one's 2. And that's why it's like it could be either or. It's all perspective. Feels good, man. Nice. Okay, cool. I think it's good.
Well done!
Ace.
Well done!
Do you have to write like E and Z? What do you mean E and Z? E and Z what? Ace. Like for cis, it's EG on the 4th column. It's 4Z. Oh, wait. 1 sec. When writing cis and trans isomers... Oh. Oh, sorry. Okay, so are you saying E on the... It's 4E? I don't know about that. E is for cis, Z is for trans. Okay, maybe. Let me just see. Okay. Yeah. Yeah, I've also seen like sin and anti. I see. Okay, got you. Right, okay. So this is E, bromo 2 chloro 1 fluoroethane. Wait, yeah, okay, cool. And then here it's Z 1 bromo 2 chloro. So the Z tells you that these are trans, I guess, right? Yeah, IUPAC. I want to know who the fuck is that IUPAC, just coming up with all these random ass rules. They're kind of fun. Oh, it's not chiral, so 1, 2, and 2, 1 doesn't make a difference. Yeah. It seems like we're not making it to Breskel's question. We might. Let's see what happens. It's the final showdown. They've both been waiting almost 2 hours. They've both been smashing the votes. Ain't wait. Well, we'll see. I might extend. I really wanted to go to the gym, but I might extend. All right, let's see. All right, here we go. Let's choose a winner. Will it choose a winner? There we go. Good.
Let's go gambling!
Oh no.
Oh my god. Oh, I'm sorry. I'm sorry, Breasticle, dude. Okay. You know, it's just the odds. The odds, Breasticles. I think you're a very lucky person. I'm very lucky and fortunate to have you in my server. If that makes any difference. To be fair, though, DM's Creator also had been in, like, kind of the same amount of time. You both were unlucky. Okay, let me just do this one, and then then I do have to end the stream. I apologize, Rusticles.
Oh no.
I know you waited a long time for your question. It's just how this is how it works. It's all good. Okay, cool. We can always do it during the next one as well. Yeah. Okay. Here we go. An 8th grade student decided to join Andre and Noah, kept track of his scores. The mean number of baskets he made is 6. Okay. Calculate MAD. Mean is that mean average distance? What's mean average difference? Difference, I think. Yeah. Oh, fascinating. Okay. Yeah. Okay, cool. I see. Yeah, because 8 is a distance of 2, 5 is a distance of 1, 6 is a distance of 0. Okay. So if you calculate MAD, right? Just add these all up. Yeah, it's not wrong. You're doing the right thing. This is right. It isn't all... Yeah, this is like poor man's standard deviation. It's like really easy. Okay, but if you wanted to do this, right? So that's 3, 4, 5, 6, 8, 9, 10, 12. So that's, and how many students are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 12 over 12. It's equal to 1. Yeah, I said yeah without thinking. Draw a dot plot to represent his data and mark the location of the mean with a triangle. A dot plot of what? Oh, I think I see what they want. I see what they want. Sorry, I think they want like 0, 1, 2, 3, 4, 5, 6, 7, 8. And then they want the mean. The mean's right here with a triangle. And then you're just supposed to say like, oh, how many... So we didn't have any zeros. We didn't have any ones. We didn't have 2... Blah, blah, blah. How many 4s did we have? We had one of them. So you just put like 1 dot. How many 5s? 1, 2, 3, 4. 2, 3, 4. How many 6s? 1, 2, 3. How many 7s? 1, 2. And then how many 8s? 1, 2. Cool. And then you can kind of see, yeah, why the mean's over here, right? You got a lot of data here, but then you got some, like, skew out here. Yeah. Gotta find the silver lining, you know. Gotta find the golden lining. Okay. Calculate the mean and standard deviations for the basketball scores. I don't know. Just plug this in your calculator. Do you actually have to do this? Like by hand? And again, to do a dot plot, right? You just put like dots. No, right? Yeah. There's actually a difference whether this is a sample standard deviation or like a population standard deviation. I don't know. Which one do you think we use? We think we use sample or population? Just use R. Like the software? Yeah, we could use the software R. I could just use chat here. Or let's use Gemini. Yeah, it's divide by n versus divide by n minus 1. Well, I mean, you would just take these numbers, you put them into a list, and then you just use stats. One second, let me find it. What calculator do you get, by the way? Do you get the TI-84? I know you probably don't get the gold one, but if you did, yeah. What calculator do you get? Do you get to do something like this? Because the way to do this is you go to here. You use computers. Oh, okay. Well, if you wanted, you could put all these numbers in a list here. You do like 81. 50. I mean, it's just a bunch of data entry. 69.
Nice.
88. 100. 75. 56. 44. 50. 81. 94. 100. 63. 69.
Nice.
94. 81. 69 again.
Nice.
81. 75. 69 again?
Nice.
Dude, what's all these scoring 69 all the time? 75. There we go. So once that's in there, you can go to stat. You can do tests. And you just say here, click one variable stats. Just hit calculate. And it'll do it for you. So there you go. So there's all your stats. So your mean is here. I believe this is sample standard deviation. And then this is population standard deviation. I think. And I think you want to sample. Yeah, no 67. So I think you want this, and I think this is this. How you do that? Let's see. What did Googly say? Googly said 15.65. Yeah, so they did this one. Okay, cool. Good question.
Well done! Well done!
Some fun stats. All right, let me add that to queue of questions we've done. Give a point to Team Scrader. Nice. Can you spin the wheel one more time just to deny Breasticles' answer?
Oh no.
Are you gonna submit something? Do you want to submit something to the queue real quick so that there's at least like so there's at least one other thing to compete against? Someone submit something real quick, please. I don't care. It can be a screenshot or whatever. You just want to give him a hollow victory? Next stream, I think Breasticles will spin. I got an ODE I want you to solve. Throw it in just to... I won't be able to answer this one because I do have to go. But I just want to see like what happens. I'm Shadow... Dude, I don't think you would lose at this stage. You have so much of an advantage. You have 1,000 votes. There we go. All right, let's see. 10 votes versus 1,000. Who would win? Breasticle's still not going to win. We're going to try it. We're going to try it out. We're going to try it out. Try it out.
Let's go gambling!
You would have won this time, Breasticles. You would have gotten it. Okay, but I do have to go. Let's close the stream.
That's dope.
All right, thank you everyone for coming to Actual Education Office Hours. Appreciate everyone who came by. This was your question we were gonna do. This is cool. I feel like this would have been. Would that have been like a Feynman's trick or something? Yeah, GG's.
Yeah, it
what
would
we
have
got
been
on?
a Diamond's trick into a wire straw substitution.
Ooh, wire straws. Wow. Someone else making graphs of things.
Yeah.
Okay, yeah. You can resubmit this for next time if you want. I'll still do it. Or do you think it wasn't hard enough and that's why the picker wheel didn't pick you?
That might have been it. So I'm looking right now at chapter 14 of my PDE book for nonlinear PDEs and calculus and variations to see if there's anything good there.
Nice. Yeah, I liked all the
If
PD
not,
stuff
I
you're
could
doing.
always hit you with the proof for pi squared being irrational.
Ooh, okay.
Which
Yeah,
is
we saw someone
about
doing
20 pages in the book I'm reading.
No, we don't need that. But we saw another person's stream that was proving like how you can determine what pi is. I think it was like converting it to a series that then converged to tangent or like arctangent, and then that comes out to be pi or something. And you're like, oh, here's how you define that.
I think I've seen something like that. I know one of like the first kind of like semi proofs, like it wasn't like an official proof, the pi being irrational. But it was something about like I forget whether it's the input or the output of your tangent. If it's rational, then the other value has to be irrational.
I see. Oh, someone says, Zach and Jeff are saying, yeah, arctan of 1 is pi over 4, and it converges slowly, and you can show from there it must be irrational. Cool. Nice. Well, all right. Our next stream, I don't think we have one on Wednesday, but make sure, come on by. Zach will be doing Diffie Q in the morning, and Penn Center will be doing math contests and homework help on Wednesday. We will be back on Thursday, sorry. So come on by for Thursday stream. We'll help you guys out with some homework stuff. And then Friday, we'll have our community recess games. So if you're in our Discord, again, go to join our Discord here. You can vote for what game we play on Friday. I think Roblox is winning so far. And then anyone who plays gets entered into a spinner wheel drawing that may pick you if your name is not Breasticles for $10. Although, Breasticles, I feel like you won one of the $10 spinner wheel things recently. I think you did. Yeah, you won the last spinner. Yeah.
Yeah, I won the one when I with the like slide and divide.
Yeah, slide and divide. You know what I realized actually, Breasticles? Someone had described the slide and divide thing to me like on a TikTok comment like 6 months ago, and I just ignored it. Like, because it was just a wall of text, and I was like,
oh no.
I just wrote some generic response of like, oh, that's cool, man. Yeah, nice. And then I saw it like come up because someone else commented it on it again. And I was like, oh, fuck. Like, I actually know what that means now. Oh. I totally just like dismissed the slide and divide person. I said, hey, whatever, dude. That's cool, man. But now I get it.
Yeah, I look to do that sometimes too.
Yeah, I'm just like, yeah, you get a cookie. Yeah, good job. There's just a lot of people. We're just flaming him at this point, yeah.
Oh no.
Okay, we're gonna go raid somebody. Who are we gonna go say hi to? Who's on? Ooh, someone's playing chess. That's fun. I do like chess. Someone's doing music. Is anyone doing science today? Most dangerous crocodile dentist. Yeah, whatever. This looks fun. Okay, cool. All right. I was pretty unhinged. Yeah. All right. Enjoy the rest of your Tuesday. We will see you guys on Thursday. Have fun. Be safe. Do math. Peace.